Hello everyone. Welcome back to my channel. Today we're going to solve a medium-level problem on LeetCode. Count the number of complete components. This problem is all about graph traversal and understanding what makes a complete component in a graph. So let's dive in and see how we can solve this problem. The problem statement asks us to count the number of complete components in a given graph. A complete component is a subgraph where every pair of vertices has an edge between them. We're given a number of vertices and a list of edges. And we need to find the count of complete components in this graph. To solve this problem, we need to understand what a complete component is. Think of it like a social network where every person knows everyone else. If you take any two people, they're friends with each other. That's what we're looking for in this graph. We need to use graph traversal to find all connected components and then check each one to see if it's complete. It's like finding all the cliques in a social network. Now let's walk through the approach. First, we need to create a representation of the graph. We'll use an adjacency list for this. Then we'll use depth-first search to traverse the graph and find all connected components. For each component, we'll check if it's complete by verifying that every pair of vertices has an edge between them. If it is complete, we'll increment our count. We'll repeat this process until we've traversed the entire graph. So let's take a look at the code. We start by creating the adjacency list representation of the graph. We have a vector of vectors, where each inner vector represents the neighbors of a particular node. We populate this adjacency list by iterating over the edges and adding each edge to the corresponding node's neighbor list. Then we have a visited array to keep track of which nodes we've visited. We initialize this to false for all nodes. We also have a count variable to keep track of the number of complete components. Now let's look at the DFS function. This function takes a node, the graph, the visited array, and a component vector. It marks the current node as visited, adds it to the component vector, and then recursively calls itself for all unvisited neighbors of the current node. Back in the main function, we iterate over all nodes. If a node hasn't been visited, we call the DFS function to traverse the component and store it in the component vector. Then we check if this component is complete by verifying that every pair of vertices has an edge between them. If it is complete, we increment our count. Now let's talk about the time and space complexity of this solution. The time complexity is O(n squared asterisk m), where n is the number of vertices and m is the number of edges. This is because in the worst case, we might need to traverse the entire graph, and for each component, we might need to check every pair of vertices. The space complexity is O(n plus m), where n is the number of vertices and m is the number of edges. This is because we need to store the adjacency list representation of the graph and the visited array and the component vector. And that's it. That's our solution to the count the number of complete components problem. If you found this explanation helpful, like the video, subscribe, and comment your approach below. Don't forget to hit that notification bell to stay updated on future videos. Thanks for watching, and I'll see you in the next one.